Right, hello everybody, welcome back to class. We have a very lovely question here, which is to look at this simple titration, the transition reaction of tetraoxobic acid and transcarbonate 4. They said 24.5 cm cube of 0.5 molar of hydrogen 2, that is tetraoxobic acid. There's no acid there. You should know that this H2SO4 is an acid, stronger for that matter, was used to neutralize 25 cm cube of Na2CO3. Calculate the concentration of the base, which is that Na2CO3. That is the question. You can see the options there. So don't skip any part of this video. I will teach you how to solve this thing one after the other. So I'm going to do it step by step. So let's go to the calculations now. Alright, the first thing we're going to do now in this question, we are going to write the equation of reaction of this experiment. Remember, we are neutralizing tetraoxobic acid and transcarbonate 4. Sodium transcarbonate 4. That is the base we are using here. So, look at the equation of reaction here. We have H2 XO4 added to Na2CO3. So this will give us Na2SO4 plus, we're going to have water because it's neutralization reaction, H2O. Then something will also be involved, this carbon dioxide, CO2. So from here now, this is the equation of reaction we are going to have. So let's check to see if our equation is balanced. We have hydrogen 2 on this side. We have 2 hydrogen here. 1 sulfur, 4 plus 3, that is 7 oxygen. 4 plus 1, 2, that is 7 oxygen. We have sodium. Sodium is 2 here. Sodium is also 2 in this place. So basically now, the equation is balanced. So this equation is very, very balanced. So we have 1 mole of this acid to neutralize 1 mole of this base to give 1 mole of each of these components here. So this one is just 1 mole. Means we have 1 here. We have a 1 here. There are some reactions, neutralization reactions like this, in which this will be, one of them will be 2 or 3 or so on. But it's just 1:1 now. So we can move with this. So number of mole of acid is 1. Number of mole of base from that reaction we did is also 1. Then from the question, volume of the acid was 24.5 cm cube. Then concentration of the acid was 0.5 molar concentration. Then volume of the base was 25 cm cube. Concentration of the base is the unknown. So concentration of the base is what we are looking for now. So how are we now going to get the concentration of the base? So we are going to use concentration equation to run this. So what is the concentration equation? Concentration of acid times volume of acid divided by concentration of the base times volume of the base must be equal to number of mole of acid divided by number of mole of base. So this is the concentration equation we use in titration or in neutralization reaction. So Ca means concentration of acid, Va means volume of acid, Cb means concentration of base, Vb means volume of base, Na means number of mole of acid, Mb means number of mole of the base. So the next thing we're going to do here now is just to make our question the subject of the formula. The question is to calculate the concentration of the base. So let me use one formula now. We're going to cross multiply this to this place. Multiply this to this place. We have CAVA NB is equals to CBVB NA. So next thing now, we're going to make this one the subject of the formula now by dividing both sides by with this. So if we divide both sides now, let's say we divide this side by VBNA, also divide side by VB VBNA. We're going to have a very lovely answer. This will cancel this. So CB will be equal to this. So let me just write it in a very clean way. CB will be CA VA NB divided by CB. Oh, there's no CB again because CB is already gone. CB is not necessarily a formula. Divided by VB times NE. So next now, let's substitute their respective value. Concentration of acid was 0.5 times volume of acid 0.24. No, 24.5. Then number of mole of base 1. Volume of base 25. Number of mole of acid 1. So if you do this very well, you are going to have 0.49. So you're going to have 0.49. So the concentration of the base now is 0.49. Concentration of the base is equals to 0.49 molar solution. So if you can also convert this one to grams per dm cube, that is mass concentration. How do you do this? You just multiply this one times molar mass of the base. Molar mass of the base. So this is correct too. This is the molar, something like in mole per dm cube. This is the correct answer for the concentration. But if you want to put it in grams per dm cube, just want to multiply the molar mass of this base because you're looking for concentration of the base. Should you do that? You can go and try that to see what you are going to have and try it. In case the options are in grams per dm cube, they will not be correction. The correction will be, remember the molar mass of N A2 CO3 was we have been calculating this now. The molar mass of N A2 CO3, which is 23 plus 12. Look at 2 here. Times 2 plus 12 plus 16 times 3. So give us 106 that time grams per mole. Yeah. So you don't do now to get the final, to get that answer in grams concentration, it will just be the 0.49 times that 106. I think that will give us something very nice. So 0.49 times 106. What are you going to have? What are you going to have there? Use your calculator, do it. 0.49 times 106. You have approximately 52. Approximately. You have approximately 52. That's what you're going to have. Approximately 52. Approximation is 51 points, like 51.94. Approximately will be 52. This one will be grams per dm cube. Or you say 0.49 molarity or molar solution. So it's either you have the calculation this way or this other way. I already showed you guys how to interconvert from here to this place. So thank you.